Okay, today what we're looking at is for our goal is I will be able to identify the differences between direct and partial variations. So it should be differences. So obviously right now, a spelling mistake, typo. Okay, so linear relationships. So this is back to what we were doing before in our last unit, but we're going to look at it a slightly different way. Okay, so the first thing we're going to look at is we already know that linear relations are relations that change and they change at a constant rate. So what happens is when we take a table of values, we can calculate that constant rate. And we know that that constant rate, we call that the slope. Okay, so we call it that constant rate a slope. Now examples would be the slope of a hill, or another example could be the speed when we're talking about kilometers per 1 hour, remember? Or if I'm talking about the pay, dollars per 1 hour. Okay, so we're talking about in those two cases, we're talking about a unit rate. Okay, and we did that actually from our previous unit, probably our very first one. Okay, so those are unit rates. Okay, and they are also related to our slope. Okay, so we know that it's kilometers, 90 kilometers per 1 hour, or it could be $10 per 1 hour. Okay, so that is unit rate. So when we're talking about direct variation, it means that there's a relationship between two variables. Usually we talk about X and Y in our previous unit. Um, However, in this case, what we do often with direct variation is sometimes we use different variables. So we might use, if we're talking about money and time, we might use P for pay and T for time. So we're still doing two variables. However, we might not always use X and Y. So the relationships between two variables in which one variable is a constant multiplier of the other. Okay, so it's a constant multiplier of another. So when we look at actually a table of values for this, okay, you can see I have time and I have distance. Now I did put X and Y here for this, but we already know that we can figure out, first of all, what the multiplier is here. And I'm just going to bring up and we're going to figure that out. So we know, for instance, that the distance between here and here is 10, 10, 10, 10. So we know this is going up by tens and this is going up by ones. And so we know already that it's a linear relationship, but the reason it's called a constant or a direct variation has to do with the fact that if I kept on going, look what happens. Okay, if I subtract another 10, this would be at 0, and my x value would be at, if I take 1 away, would be at 0. So this is what happens if I'm looking at this, is with a direct relationship, if I looked at the table of values, where x is 0, y is at 0 as well. Okay, so when we're actually looking at this one, you already know that, go back to my green, that my slope is going to be 10 over 1, which is 10. Okay, and we could actually then look at the between x and y if we want. That is our constant rate. So the difference between distance and time. Okay, distance and time. Remember when we do slope, it is delta y over x, which is also this here. What we end up with is distance over time is the same as our slope, which is a constant rate. And when we're talking about direct relationships, what we do is we sometimes give it another name. And the name that we give it is called the constant of variation, which almost seems like an oxymoron, not moron, moron, um, if we're talking about English. So we're talking about a constant of variation. And you're saying that's kind of doesn't make sense. How can something be constant and at the same time vary? Well, it's constant for this question, but it varies to another question. Okay, so often what they use then for the symbol for that constant, they use the letter K. Now, does it really matter that they use the letter K? Not a whole lot, other than you'll see, for instance, M also equals this constant of variation. So they're interchangeable here. So what happens is when we look at the equation for, first of all, this above example, if we want to do that first, we know that we can use y equals mx plus b, because we've been doing that. And in this question, we know that our slope is 10. And so it would be 10x. But what about our b value? Well, b, remember, is our y-intercept. Our y-intercept here is when x is 0, y is 0. So really what it is, it's plus 0. So all direct variations, what happens with them is all of them are in this kind of form. They're in the form y equals kx, or in other words, y equals mx. And the graph of a direct variation will always go through 0, 0. Okay, so because this is direct, and I'm just going to go back up to this question again, because my constant of variation is 10, if I take any x value, I can figure out the y value by that, because I just take that x value and multiply it by the 10. And you're saying, well, yeah, well, that just makes common sense. It does, but it's a special kind of relationship that we study. Okay, so on to the next page. So what do we have to do? Okay, so this is the type of word question that you often see. So we have a family that travels 250 kilometers. The distance d varies directly with time t in hours. Okay, now first of all, let's take a look at this. English, the way that they work with it is often they'll have distance, and then they'll put, sometimes often they'll put a comma here, distance, comma, d, comma. So distance, we're going to use the letter d, varies directly with time t. So our time is going to be t in hours. So instead of using x's and y's, we're going to be using d's and t's. Now this comes back to when we talk about dependent and independent variables here. So when we're talking about what one would we consider to be what our normal x and y would be? Well, that comes to the point of dependent and independent variables. So in this case, time's going to happen whether we travel or we don't travel. So time actually is like our x. So it is like our x because it is independent of whether we're traveling or not. And our distance is going to be related to the time. So the first thing it says, find the equation relating to d and t if d equals 43 and t equals 0.5. So find an equation. Well, I've already told you a few different things in this question, and the first thing that's really important for us is it says it varies directly. So as soon as I see that, I know that it has to be in a certain form. And the form it has to be in is that y equals, and I'll just put it, oops, sorry about that, y equals mx, or because we're talking about relationships here, or y equals kx, same thing. Now, how do I figure out what my K value is? Well, K in this case is going to be the distance divided by the time. Okay, because we're interested in the kilometers per hour. Okay, kilometers per hour, because that's what's going to give us kilometers divided by time. Okay, so if we looked at this, if I was graphing it, my time, in this case would be hours, would be along my horizontal axis, and my distance, which is my kilometers, would be on the vertical axis. Okay, so that's why it's in that form. So distance divided by time. So y's divided by x's. So even though we're using d and t, the same principle applies. So how do we figure this out? Well, let's do it. So distance, they traveled 43 kilometers, because it's in, distance is in kilometers, 43, and it took them 0.5 hours to do that. So what would that be for 1 hour? Okay, so all I have to really do is 43 divided by 0.5, or double 83. So we end up with 86. Or double 40. Yep, I think I said that right. Sometimes I forget what I say. So what happens is that is our K, and we're going to actually put it into our K. So if we followed this, we would go y equals 86 times x. Now, because this question uses d's and t's, I have to change my equation, because my equation doesn't define x's and y's, it defines d's and t's. So my distance then is d equals 86 times t. Okay? These mean the same thing, it's just that the d and t have been defined up above for us. Now the next thing says, use the equation to determine the length of time required to reach their final destination. So this is actually pretty easy. So it tells me to use my equation, so I better use my equation. So d equals 86t. And how long was their trip? Well, it said their trip was 250 kilometers. So they told us the distance was 250. So that means I need to substitute that 250 in for d. And now I'm going to solve for time. Okay, so we've done questions like this before. How do I get t by itself? Well, obviously I am going to divide both sides by 86. And when I divide both sides by 86, I end up with, wish it would just stay on that thin thing, but it doesn't, approximately 2.91 equals t. So it's a word question, so therefore I would put, therefore it would take 2.91 hours. Okay, so pretty straightforward, especially since we finished our previous unit, because these are highly related. Now this is called a direct variation. Tomorrow's lesson is on what we call a partial variation. You'll see how they do change. So it's going to take us a couple lessons to figure out the difference between direct and partial. Okay, so some questions from your textbook tomorrow.